Hello, this is a demonstration of how math accessibility should work when using NVDA and Math Player by Design Science. I'll put links to those items in the description of the video, but know that if you install those two tools on your system and if the math in question is coded correctly, you should be able to hear and navigate equations in a systematic and sensible way.
Meeting control.
For this example, we will be using the Wikipedia article on the Nyquist-Shannon sampling theorem. We're using this example because
Nyquist.
last night I couldn't sleep and I got so excited about watching a YouTube video about this theorem, which I'll also put in the description box, that I went and read the proof of this theorem with a refreshable Braille display. This was possible because of technologies like MathJax and Math Player and NVDA. So it's important to create accessible STEM content, obviously, and this is a good example of why. So to start off with, I will have NVDA read the beginning of this Wikipedia article so you can sort of get a sense for how a screen reader sounds if you haven't heard it before.
The Nyquist-Shannon sampling theorem is a theorem in the field of link signal processing which serves as a fundamental bridge between link continuous time signals and link discrete time signals. It establishes a sufficient condition for a link sample rate that permits a discrete sequence of samples to capture all.
Okay, so since I already watched the YouTube video about this and I kind of know what I'm looking for, I just want to look for the proof of this theorem. Usually, I can accomplish this with heading level navigations because I've read enough math articles on Wikipedia to know that there's usually a proof somewhere in the article. So I also know that the main level to be concerned with of Wikipedia articles is heading 2. So if I press the 2 key,
navigation landmark contents heading level 2,
I'll be taken to the table of contents where I could look for the proof, but it's actually easier to just press the 2 key until I get there.
Introduction, edit link, edit section.
Introduction, already watched the YouTube video, so I don't need that.
Aliasing, edit link, edit section. Derivation as a special case of Poisson summation, edit link, edit section. Shannon's original proof, edit link, edit section. Shannon's original proof heading level 2.
Shannon's original proof. So here should be the proof. And so I'm going to start reading. And by the way, I'm not doing say all because in technical articles, I prefer to press the down arrow key and digest information in little pieces. Say all sort of is more difficult to stop. So you'll hear pauses, and that's because I'm pressing the down arrow. I'm not doing a say all.
Poisson shows that the Fourier series in visited link EQ.1 produces the periodic summation of x of f regardless of f sub s.
Okay, well, we already have a problem. The article refers to equation 1, so I must have missed something. Whatever shall we do? Let's press tab and activate the equation 1 link and see what equation 1 was.
EQ.1 visited link.
Okay, and it's visited because I did a run through of this before I started the video. So if I press enter,
list with 1 items, EQ.1.
Equation 1. So this is going to be the first equation that we read in full in this article.
Blank, blank, blank.
Sorry about that. There's
x sub s of f delta equals the sum from k equals negative infinity to infinity of x times open paren f minus k f sub s close paren equals the sum from n equals negative infinity to infinity of t times x times n t times e raised to the negative I 2 pi n t f power.
Okay, I hold a Bachelor of Science degree in pure math, and I cannot parse that equation as it was just spoken. So luckily for us, Math Player comes to the rescue and allows us to navigate this equation structurally and hierarchically. So what do I mean by that? Well, normally when you navigate with the arrow keys with NVDA, you navigate by character or line. Left and right arrows navigates you between characters in a line, and up and down arrow navigates you between lines. Navigating by character isn't always a sensible way to navigate math equations. With math, you want to navigate more, you want to be able to granularly navigate between pieces of information. So
space,
if I go to the beginning of this line and press the right arrow one time,
space,
well,
blank,
let's
blank,
see. If I go
x sub s
to
space,
the beginning of the line with the equation and press the right arrow one time,
space,
why isn't it
blank,
moving the arrow
space,
to the equation?
blank, space, x sub s of f,
There we go.
space.
Okay, sorry about that. If I'm going to press left arrow actually one time, and this is what it's going to read if I press the arrow key one time.
X sub s of f delta equals the sum from k equals negative infinity to infinity of x times open paren.
Okay, it's going to read the entire equation. So if I press enter,
math x sub s of f delta equals,
something magical happens. It says the word math. And now, if I press the arrow keys,
delta equals,
I can navigate by a more reasonable chunk of information, which for this giant equation, I need to process it in pieces. So
x sub s of f,
x sub s of f. Okay, that makes sense to me. But if it didn't, I could press down arrow.
x sub s of f.
And then if I press left and right arrow,
x sub s of f.
I get x sub s of f. If I press down arrow again,
x sub s.
I get x sub s. So if I couldn't hear it or if I didn't know what a subscript was, I could navigate very finely. I could zoom into this little part of the equation.
In base x.
So now it says in base.
In subscript s.
In subscript s when I press right arrow.
Out of subscript of f.
Out of subscript of f. So at this level, I'm kind of navigating by character.
Delta equals the sum from k equals negative infinity to infinity of x times open paren f minus k f sub s close paren equals.
Okay, that makes more sense. So we've got a summation from negative infinity to infinity of f minus k. So you can kind of navigate hierarchically, which is a big deal. One of the ways that I explain this when I present on this topic is if you were a sighted person and you got a math book with print descriptions of equations instead of the equations themselves, that would be unacceptable. The way that sighted math readers read equations is they sort of read them recursively or hierarchically. So without getting too into it, this plugin for NVDA allows a speech user to navigate equations in a similar way. It also allows users to choose their grammar, which is important for things like statistics, where symbols mean different things than they do in the field of real analysis, for example. So that's a little beyond the scope of this video, but let's, now that we've looked at equation one,
x sub s of f.
And by the way, I just jumped to equation one without looking at the context of it. If I wanted to do that, I could use my heading level navigation to see what section of the article equation one is in. What section would that be? Shift H will tell me
Aliasing edit link edits.
that it's in aliasing. Okay. So this is an example of how all of these universal design things can work together to provide a good unified user experience to someone reading an article. So if I wanted to, I could start reading this section about aliasing.
Main article, link aliasing, link file CPT sound Nyquist theorem, link enlarge. The samples of two sine waves can be identical when at least one of them is at a frequency above half the sample rate. When x of t is a function with a link Fourier transform x of f.
And by the way, the x of t is coded as math. So if you wanted to, you could navigate to it.
X of t.
X of t, it said that with one press of the right arrow key. So it's not treating this quite like a character, like a normal character in NVDA. But if I press enter,
math, x of
it says
t.
math.
Zoomed in all of the way x.
And it says zoomed in all of the way because this expression is so small that there's only one level of zoom. There's x
of t.
And here, if I wanted to, I could probably zoom in a little bit more.
Zoomed in all of the way t.
Nope, it's x of t.
Argument of x of t.
So for smaller equations,
when x
you can still kind of navigate it, but there's not as many levels of zoom. Okay, so now that we understand equation one, let's go back to the proof. We can do that very easily with heading level navigation.
Derivation as a special case of Poisson summation edit link edit section. Shannon's original proof edit link edit section.
Okay.
Poisson shows that the Fourier series in visited link EQ.1 produces the periodic summation of x of f regardless of f sub s.
And now we know what f sub s is, and we know what x of f is.
And B. Shannon, however, only derives the series coefficients for the case f sub s equals to B. Virtually quoting Shannon's original paper, list with one items left let x of omega be the spectrum of x of t. Then, out of list with one items x of t equals 1 over 2 pi, the integral from negative infinity to infinity of x of omega e raised to the I omega t power d omega equals 1 over 2 pi, the integral from negative 2 pi b to 2 pi.
And I immediately recognize that as a Fourier transform from taking Math 309 at the University of Washington. But you could do a similar thing with this equation. You could explore it hierarchically. You could zoom in and out, and you could process it one little chunk at a time, which is very, very helpful when digesting these proofs that have a lot of this kind of a proof has a lot of complicated symbols, but it's not actually that complicated once you understand that there's just a lot of Fourier transforms going on. So hopefully this has been kind of a good explanation of how this works. The other great thing that it does, and actually the main way that I do this, is I read it in Braille because I'm used to reading this kind of thing in Braille. So you can also hook up a refreshable Braille display if you have this all set up correctly, and you can get Nymeth or Unified English Braille output from your screen reader. So thank you for watching. I hope this has been informative, and go make some accessible math.
Meeting control mute. Stop.